Good morning to all. We have completed the chapter first of the chemistry, chemical equations. Chemical equations. I think almost all of them will read the lessons, go through the passage and try to answer the questions. The answer to questions are already given. You may try to answer it. The questions are direct and you may face no problem, no difficulty in answering it. The coming examination, the coming monthly test, ask questions from this chapter. So, once more we can have a revision. We had already learned several things. We can conclude it in a one sentence. All our studies are round about chemical reactions and equations. Chemical reactions and equations. Chemical reactions. What do you mean by chemical reaction? It's a chemical change. The starting of the topic is physical change and chemical change. Distinguish between physical change and chemical change. There are two differences. We seen that on tearing a paper, it is a physical change. In physical changes, no new products and changes are temporary. Physical changes are temporary and no new products are formed. At the same time, chemical changes are permanent and new products are formed. In this chapter, we have seen a number of reactions. In all the reactions, there is a reactant side and a product side. Then we can go through the chapter once again. What is a chemical reaction? It is a symbolic representation. What is a chemical equation? Chemical equation is a symbolic representation of a chemical reaction by symbols and formula. What do you mean symbols? You have already learned about 1 contain 18 elements. The symbols are its shorthands of the name of the elements. Symbols and formula. Formula means the symbols as well as the formula of chemical formula of the molecular formula of the compounds. Then the several classifications. These are all leads to a chemical reaction. What is a chemical reaction? In a chemical reaction, the reactants are reacting to give products. What are the changes occurs in a chemical reaction? What are the changes occurs in a chemical reaction? We can note one more changes. In a chemical reaction, there is an evolution of a gas. Can you give an example? The reaction between zinc and sulfuric acid. Zinc sulfate and hydrogen are produced. Well, the changes we can see occur in a chemical reaction. The evolution of a gas, second, change in temperature, where we can see change temperature. In a test tube, we take zinc granules. Zinc granules are taken. Sulfuric acid is poured on it. Nitrous oxide is poured on it. Sulfuric acid reacts with the zinc granules, producing hydrogen gas. And at the same, if we touch on sides of this tube, we can feel a hot. This reaction, heat is also produced. Evolution gas, change in temperature, change in color. When lead nitrate is added to potassium iodide, we get an yellow precipitate of lead iodide. This lead iodide is yellow in color. The nitrate is a white color. This evolution gas, change in temperature, change in color. In this reaction, you have noticed two things. Once, change in color. The red iodide is white, and at the same time, the yellow precipitate of lead iodide is formed. Lead iodide is yellow in color. Yellow precipitate, the insoluble substance produced in a chemical reaction is known as precipitate. We have seen that in a chemical equation. We may note whether the reactants or products are the solid state, liquid state, gaseous state, or in the aqua state. Aqua means dissolved in water. Precipitate means it does not dissolve. The made the equation more informative. In addition to the we write on the states of the reactants and solids, we have to write three more things. Whether it's the aqueous state, whether any precipitate is produced. At the same time, we may note the reaction conditions. The temperature and pressure may be noted if required. Then the equation become more informative. In ordinary conditions, certain reaction does not take place. If certain reaction to be take place, the conditions must be changed. That conditions are known as optimum temperature or optimum pressure. Then this is lead iodide. You can see the change in color. Then change in state. Solid state may liquid change to liquid, or liquid state may change to gaseous state. So these four changes can be noted in a chemical reaction or evolution of a precipitate form. Production of precipitate. So these five changes in every chemical reaction, one or more of this reaction we can see, we can note one or more of this reaction. These changes, evolutionary gas. For example, in a reaction, there is maybe an evolutionary gas. Any metal react with acids, hydrogen is produced. Not only the zinc, magnesium, or any other metal reacts with the acids. Any metal reacts with the acids, it produces its own salt and hydrogen gas are produced. Zinc reacts with the hydrochloric acid. Zinc, chloride and hydrogen are produced. The common concept is any metal react with if it is reacting with acids, the first product is its salt and second product is hydrogen, because every acid contains hydrogen. Then the reactions can be, on seeing a reaction, we can see the chemical reaction. For example, 2Ng plus O, O2 gives 2NgO. We look at this reaction. On looking at this reaction, we can see all the things what we studied in this chapter may be applied to this equation. One, what are the reactants? Second, the products. Third, whether it is a balanced equation. We can also note the chemical formula are correct or not. NGO, O2. You cannot see first on seeing an equation on the reaction. First we note whether the chemical formula of the elements and compounds are whether it is correct or not. The third, whether it is a balanced equation. Again, we can classify this. We can see this. We can see again. It can be noted that what type of reaction. What type of reaction? What type of reaction means whether it is combination reaction or decomposition reaction or displacement reaction, the form it is double displacement. On this reaction you can note the following: whether it is a balance equation. We have already learned that how to balance equation in the given note. The note given to you is clearly mentioned how we can balance a chemical equation. The next thing we can again repeat it. Where one type of reactions, whether it is a combination reaction. How we can identify a combination reaction? In a combination reaction, we already studied that only one product, A and B combined to form AB. It is the form A plus B gives AB. So it is a combination reaction. We does not choose from this whether it is a decomposition. In a decomposition reaction, only one product, reverse of this. Whether it is a displacement reaction. In displacement reaction, the general form is AC plus B gives A plus BC. The one element displaces other element. The more active element displaces other element from its compound. There are three components, and the fourth is this double displacement reactions. These things we can notice. Then again, first of all, on seeing a reaction, all the things, all the matters described in this chapter are around the type of chemical reaction. We have examining carefully the reaction. What are the reactions? What are the products? Whether it is a balanced reaction or not, whether it is a balanced reaction or a skeletal reaction. If a skeletal reaction is, we have to balance the equation. Then what type of reaction is? We have already studied 4 types. Then there are one more thing, redox reaction. It's a special unit, you have to study it, revise it after this. Then we have already learned that it is a combination reaction. Combination reaction. Then we can again classify it into several other types. The combination or decomposition reaction may be again classified into other types, that is whether it is exothermic or endothermic reactions. Whether it is exothermic or endothermic reactions. What will be exothermic? Exothermic reactions are those in which heat energy is liberated. Heat energy is liberated. The heat energy liberated can be noted by a symbol like this. This symbol denotes heat energy. In spite of radiating heat, we can use this. In this, because in this activity, burning of magnesium burns in air with a dazzling flame. What do you mean by dazzling flame? Magnesium burns in the outside with a dazzling flame for magnesium oxide. Because at the same time, heat energy and light energy are also produced. More is heat energy. This is an exothermic reaction. We studied that exo means exit. Thermo denotes temperature, or heat. This is an example of exothermic reactions. Then we can see the other type, endothermic reactions. CaCO3 gives CaO plus H2O. CaO plus CO2. What does this symbol denote? This symbol denotes heat. Calcium carbonate on strong heating, it decomposes to give calcium oxide and carbon dioxide. Carbon dioxide gas is evolved. Here we can say that the first, the initial, this is the evolution of a gas. But here carbon, the symptom of a chemical reaction is, there may we can see either evolutionary gas or change in state, change in color, production of precipitate, and so on. Here we can see the evolutionary gas. Then this is an endothermic reaction. What do we mean endothermic reactions? It is just opposite of exothermic. In exo means exit, heat evolved, heat released. Here endo means heat absorbed. These endothermic reactions are again classified into three. One, thermochemical. The other is electrolytic. The third is photolytic. Perhaps with may not have seen the textbook. Yes, you have to familiar with what is thermal decomposition. During a chemical reaction or during an endothermic reaction, endothermic means reactions in which heat energy, either heat energy, light energy or electrical energy are absorbed. The three forms of the energy which are associated with the endothermic reactions are heat, light and electricity. If heat energy is absorbed, it is known as thermochemical reactions. If electrical energy is absorbed, it is known as electrolytic reaction. If light energy is absorbed, it is known as photolytic reactions. So, we can again give the endothermic reaction. Endothermic reactions are those reactions in either heat, light or electrical energy is absorbed. It said if certain reactions are to be taken place, we have to give heat or light or electricity. If heat is given for this reaction to be take place, it is known as thermochemical reaction. This is an example of thermochemical reactions. Thermochemical reactions. Here another example, bond heating parasulfate. We can get FeO2 plus SO2 plus SO3. The color of parasulfate is green. If a green color parasulfate on heating, what are the products formed? Ferric oxide, sulfur dioxide and sulfur trioxide. We can see two changes here. The color of the parasulfate is green. On heating it changes to brownish black ferric oxide, and at the same time a smell of burning sulfur is spread through the glass wool. Sulfur dioxide and sulfur. It is also an example of endothermic. It is an example of endothermic reaction at the same time thermal decomposition. That is, this decomposition is brought out by heat. Then we can go to other examples. Electrolysis of water. Can do a simple diagram. Please look here. In there is a beaker. It contains water, not pure water, acidified water. Please be note here. What are the apparatus? A beaker containing acidified water. By pure water does not conduct electricity. So, to make the water conduct electricity, 1 or 2 drops of acid, base, or in salt is added. Then there are 2 electrodes. These electrodes are made of graphite electrodes. This is a 9-volt tri-cell. 9-volt cell. This is positive and this is negative electrode. The positive electrode is known as anode. The negative electrode is known as cathode. You have already studied in physics class also. Then electricity class also, what we can see in anode, oxygen. At cathode, hydrogen. Then we can see what is the reaction takes place. Water or decomposition gives H2 plus O2. Where hydrogen is liberated and where oxygen is liberated. Hydrogen is liberated at the cathode and oxygen is liberated at the anode. Why? Hydrogen is positive ion and oxygen is negative ion. What are ions? Electrically charged atoms are called ions. Electrically charged atoms are called ion. Hydrogen is positive ion and oxygen is negative ion. Hydrogen is positive and oxygen is negative. Positive ions are always attracted to the negative electrode cathode. And oxygen is a negative ion, it is always attracted to the positive electrode. The name of the positive electrode is known as anode. So, ion passing electricity through acidified water, the electrical energy is absorbed and it decomposes to give hydrogen and oxygen. We may ask here arise one doubt. Hydrogen is a special element. Hydrogen is the only non-metal which is liberated at the cathode. Normal cases, metals are positive ions and liberated at the cathode. There is one non-metal, only one non-metal which is liberated at the cathode is hydrogen. So, in your periodic table, we can see that where is the position of the hydrogen? Hydrogen is placed on the first element, the first group top. It does not connected to the first island. Yes, it's a certain speciality you can see that. Yeah. So now I have to give one activity. If you are a science student, a small periodic table like this can be placed on the study table. How we can? Whenever you are studying chemistry, you can have a look at the periodic table. How you can produce like a periodic table like this? First of all, you have to take a cardboard binder. You are an old notebook. Old notebook. It is the pages are removed and the bind is taken on the one side, and there is a separate. The bind is taken like this and a cardboard is cut and placed in between them. Then the one side you can take a photocopy of the period table, or you can download it from the net. Then a period table is one size is taken and is pasted on the one side. The other side, now you write the type of chemical reactions. Then whenever you have a look at the table, there are something you have learned is fixed on your mind and you can repeat it the examination. So today itself in your study table, you have to make such a period table like this and place on table. And every time when you are studying, the elements, the positions and the symbols, their atomic number and mass number are necessary in every time when you are, if you are a science student, especially when you are studying chemistry, this is needed. So today itself, you make a simple, a small period table and place it on the study, your study table. It's like how to make, you only, there is no expense. The bind of a old notebook and a small period table which can be taken, download from a net and take a printed copy. If one copy is taken, then you can take photocopy and this is on one side you make the period table, the other side you can change the, now in this chapter you can write the chemical equations and the type of reactions. Now you are studying about, you have to do it this week. Today you don't get, today you don't get time, you do this activity in this week. This is an electrolytic reaction. Then there comes the other reaction, photolytic. What is photolytic? Photo means light. Photosynthesis. The plants produce food during daytime or during light. That's photosynthesis. Here certain reactions are to be taken. If certain reactions are to be taken place, light energy is needed. That is used in photography. In photography, the photographic film is coated with a compound named silver bromide. Silver bromide. It is in presence of sunlight or it absorbs sunlight and gives a grey metal of silver and gold. So this this is the principle in black and white of photography. The black and white of photography, the film is coated with the silver bromide. This film is coated with the silver bromide. On taking photo, what happens? We use in the flashlight of the camera. On taking photo, the flash produced by the stuck onto your body and reflected and turned to the this photo stuck on this film. Then what is your shape? This is where the light touches the film. On that part of the silver bromide undergo chemical change. Then your photo is placed here, fixed here. So if this film is coated with the silver bromide, by taking photo, it undergo changes or in presence of during the flash of the light. This part where the shape, as the shape of the person or a thing, it undergo changes. So this is the photolytic reaction. This principle is used in photo, black and white photo. Similarly, silver iodide or silver chloride is placed in sunlight. It also undergo chemical change. So endothermic reactions are exothermic reactions, endothermic reactions, and endothermic reactions are again classified into three, that are thermochemical reaction, photolytic reaction. The term is used not here, but certain reactions are to be take place only in presence of sunlight or light. That are called photolytic reactions. And electrolytic reaction, give an example. In the electrolytic reaction is the electrolysis of water. During electrolysis, what are the which material is used for anode and cathode? Graphite is used as the anode and which is anode? The electrode connected to the positive rod is called a positive pole is called anode. The electrode connected to the negative pole is called cathode. Which are the elements liberated at the cathode and anode? Positive ions liberated at the cathode and negative ions liberated at the anode. Opposite charges attract each other. Here we have seen that hydrogen and metals are always liberated at the cathode. All the non-metals liberated at the anode. Hydrogen is like hydrogen has a dual behavior. In the case of non-metals, it behaves like a non-metal. In certain cases, it behaves like a metal also. That is, says that hydrogen is a dual behavior. So hydrogen and metals are always liberated at the cathode. And then we have seen that in the test tube where oxygen and hydrogen liberated, we can see the ratio is different. The oxygen collected is half than that of hydrogen liberated. Why? In water molecules, the ratio of hydrogen is to oxygen is 2:1. So this is the case. Are you understand? H2 volume, oxygen 1 volume, that is half volume. That oxygen is half volume. Well, the answer is what? In H2O molecule, the ratio of hydrogen to oxygen is 2:1. Where does the 2 is come? 1 come? 2 hydrogen 2 atom, oxygen 1 atom. Then that is the liberation is that way. If 2 atoms of hydrogen are liberated, 1 by 1 atom of oxygen liberated. So the volume of half oxygen is half than that of the hydrogen. Then there are other equations, that is redox reaction. There may be some of it displacement reaction and displacement reaction, double displacement reaction. Displacement reaction. It has a general formula. A plus BC gives AC plus B. For example, this is copper sulfate is taken in this. If an iron bodies imagine what happens, iron liberated copper from the copper sulfate. If a zinc bodies imagine, zinc also liberated copper from it. If a lead is lead also liberated, the more active element it displays the less active element from its copper. That is known as displacement reaction. Iron plus copper sulfate gives HbSO4 plus copper. This displaced copper is thrown out copper. It cannot be deposited on the surface of the iron rod because it needs the activity. In the case of iron, if we use the zinc or lead, the same result we can see. This is displacement reaction. Lead monoxide on heating magnesium. You can see the same result. Lead plus magnesium oxide. Lead monoxide on heating magnesium, we can see lead plus magnesium oxide. Here also displacement reaction. Oxygen is displaced from lead oxide. This is a displacement reaction. At the same time, it is a redox reaction also. We can see it after this. Then there is double displacement reaction. How can we define it? You can see the general formula AC plus BD. Two components each gives AD plus BC. the two reactors exchange their components. This is known as double displacement. In the case of displacement, only one of the element of this react displaced. Double displacement, two components are displaced. That is only difference. Then you have to go to the redox reactions. In redox reactions, we can see number of reactions. The first activity is on heating copper. Copper oxide is formed. On heating copper on a China dish, you have now the color of the pure copper is like a gold shiny surface like golden color. On heating it oxygen, it forms black copper oxide is formed. This N element combines with oxygen, that is oxidation. When you pass hydrogen over this copper oxide, what will happen? This oxygen is removed. This oxygen is removed. This removal of oxygen is known as reduction. For first you have to learn one thing. Oxidation is a combination of oxygen. Reduction is the removal of oxygen. There may be one more thing. Oxygen is the addition of oxygen or the removal of hydrogen. That is, you don't go more, not give more importance to case of hydrogen. You have to know the first thing. Then this is the removal of hydrogen. The more important thing you have to notice here is, on the case of redox reaction, you have to do only on the reactant side. Only on the reactant side. While writing the substance oxidized or the substance reduced or the oxidizing agent or reducing agent, you never write the formula on the right side. The four things. What are four things? The substance oxidized. Here, the substance oxidized means the hydrogen. Hydrogen combines with oxygen. Hydrogen combines with oxygen. The substance oxidized is hydrogen. That means combination. Hydrogen combines oxygen. Oxidation is the combination with the oxygen. So the substance oxidized hydrogen. Substance oxidizes substance hydrogen. Then what is oxidizing agent? Copper oxide. If copper oxide does not give the oxygen to hydrogen, it does not undergo oxidation. Hydrogen undergo oxidation by copper oxide gives oxygen. So hydrogen undergo oxidize this hydrogen. The cause of the element is, the cause of substance is copper oxide. So, substance oxidized hydrogen, oxidizing agent, copper oxide. Then come to the next. What is reduction? Removal of oxygen. Here oxygen is removed, so it reduced. Reducing agent is hydrogen. If the reaction, so by writing the four things, you don't write anything from the right side. The four things, oxidized, oxidizing agent, reduced, reducing are on the reactant side itself. You can find more things from the reactions from the test tube. You look at these two things also. Then there is the other thing, corrosion. The last class I have seen you rusted piece of iron sheet. All the metals when we expose to air, if there is a reactive, if there is a reactive element, this metals reacts with the oxygen, moisture and carbon dioxide and form a coating on it, and it undergo corrosion. The other that the aluminum vessels. If you purchase from the shop or the because it has just a shiny surface. After some days of cooking, the color of surface changes to a dark, the shiny surface and shiny color disappears. How? By oxygen aluminum metal on heating, it suddenly commits oxide to form aluminum oxide, a coating on surface. If we don't heat, it takes several days to take a coating is formed. Like is copper. What is the coating formed in the surface of copper? In Malayalam you get it clav. What is the English name? Verdigris. If copper or copper plate vessels or copper plates or is placed in some days or some weeks, some months after it changes its color. How it copper verdigris is formed? Copper reacting with the oxygen, moisture and carbon dioxide, and that has formed a basic copper carbon. That is known as verdigris. It has a green color. The color of verdigris is green. At the same time, we already know that the gold ornaments does not change its color. Why? Gold is a less reactive metal. Gold is less reactive. It does not, under normal conditions, it does not give electrons or does not combine with oxygen or any other substance present in the air. So it does not undergo color change even after years. At the same time, silver ornaments undergo corrosion. It reacts with the silver metal, especially reacts with the hydrogen sulfide present in the air and to form silver sulfide on its surface. The black color, you have seen that, you observed today itself, some of the silver ornaments, its color changes quickly due to the coating is silver sulfide. How silver sulfide is formed? The silver metal reacts with the hydrogen sulfide present in the air. A mining country with the decay of plants and animals, hydrogen sulfide is produced in the atmosphere to a little country. This hydrogen sulfide reacts with the silver metals to form silver sulfide. So it undergoes the color of the shiny surface disappeared and a black color is also formed. And the last is density. These are all familiar to you, this reaction. What is meant by density? The familiar term, it means spoilage of food items and gave a bad smell, bad odor and bad taste, especially the food materials containing fat and oil. If it is exposed in a sealed airtight container, if it is kept in an airtight container, density does not take place quickly. Well, now you have to favor. These things you don't to learn by heart. You look at the things, what was happening in your kitchen. Density means spoilage of food items. Well, you see that some the food items including chutney, pickles, etc. are undergo, and the bakery items are also undergo spoilage if we kept exposed there. The second is how this happens due to the oxidation. If we open the notice airtight, if it's open, air is get inside the tin, inside the container, where the things, especially fats and oils, undergo oxidation. Present in the oil, it reacts with oxygen. You have already know that oxidation is a combination with the oxygen. This is how this density is due to oxidation. Then how we can prevent it? Oxidation can be prevented by antioxidants. If we add antioxidants to the material, to the food items, density can be prevented. What are antioxidants? The materials which prevent the oxidation of the food material, or the materials, the things or the chemicals which prevent the oxidation of the or the density of the food materials are called antioxidants. For example, we have seen that the chips items we have purchased from the bakery, the bag is filled with the nitrogen gas. Why? Nitrogen is chemically inactive. In certain tests in our class, nitrogen is an inert gas. Nitrogen is not an inert gas. Chemically, it reacts like inert gas. Nitrogen reacts like inert gas means normal conditions, nitrogen is very inactive. So, the bakery items chips are filled with the nitrogen. Now, what nitrogen is an antioxidant. This must be you study about corrosion and density. In the case of corrosion, the metals react with the surrounding, the substance present in the atmosphere, and it undergo corrosion. And how we can prevent corrosion? There are three things. We apply paint. What's the principle involved? We apply paint on the surface. The metal cannot contact with the air. Then we see that in our house. Then I apply oil on the surface. The principle is same, to prevent the contact with the air. Then the third thing is we can prevent it by making alloy with the other elements. Corrosion can be prevented by. Okay. Then you go through each page, each sentence and each line of your test. Then there is any special notes or the chemical name is given, you specially note it. For example, the chemical name of marble is calcium carbonate. Similarly, calcium oxide, which is prepared by heating calcium carbonate. This calcium oxide is used for make the production of cement. Similarly, the oxides of iron. The oxides of iron in your textbook. Ferrous oxide, FeO. This is ferrous oxide. In ferrous oxide, iron is in the positive 2 oxidation state. Similarly, ferric oxide. This is iron is in the positive 3 oxidation state. Then in your textbook, Fe3O4. This is ferroso-ferric oxide. Commonly it is called ferric oxide. It is a correct name is ferroso-ferric oxide. It is not an oxide, it is only a mineral named hematite. It is a mineral of iron. Similarly, rust. Rust is hydrated ferric oxide. Fe2O3 XH2. You may please note these oxides. Iron is very familiar to use, very common use in our home. So these oxides are given in textbook. You must also give these particular kinds of oxides. Iron forms mainly ferrous and ferric. Because iron is a transition element. Iron is a transition element. So it is called it form two oxides, ferrous oxide and ferric oxide. This is a Fe3O4 is a mineral of iron. Hematite is used for the production of iron. Then rust, and this is hydrated ferric oxide. So it is not given to exercise. You must go through this each line of the test. Then read carefully. Now you ask yourself the questions and find answers from the test itself. The examination is coming soon. You ask questions from this chapter. All the answers to exercise are given to you. These are some direct questions, and you may find no difficulty in answering these questions. Then, I think you have got a clear idea about what is a chemical reaction. Then, I will give you two activities. As I said earlier, first of all, you made a tabletop periodic table. Second, you don't limit your studies this chapter only. You go through the next chapter and read the equations given in the chapter are written on your notebook and analyze the equations, whether it is balanced or unbalanced, redox reactions, and which type of reaction each one. Then you find no difficulty in this chapter also. Okay, wish you all best. You will write that exam neatly and score high marks. Thank you.